For more than 3 decades, technological tools have been an integral part of mathematics teaching and learning. From graphing calculators to dynamic geometry software, and now to AI-powered platforms, these tools have continued to evolve. But are we truly making mathematics pedagogy more effective, meaningful, and relevant with these technologies? Or are we simply layering innovation on top of old habits? In this keynote address to the Hong Kong Mathematics Education Conference 2025, Dr. Arthur Lee invites us to reflect on these questions. He examines how common teaching approaches using digital tools have or haven't evolved, and what that means for our educational goals today. His insights will challenge us to rethink not just what we use in the classroom, but also how and why we use it.
This is definitely a great honor for me to be here sharing with you today, this morning. I will better focus on something in the past, right? Since we have also different kinds of innovations, perhaps we can also have some time to think about our experience in the past. So if you're interested, you can also come to my website and then find the link, okay, to some of the materials I'm going to present. Basically, I prepared a very basic and simple set of slides. Now let's start with journey, okay, because it's the theme of our conference here. And so when we talk about journey of innovation, I first think about what kind of journey we are considering, right? How long has it been? And where do we want to go, okay? Now, in fact, I think for different people, right, this journey may be short or long, right? For me, it's already quite long, I would say that, okay? Just because there are different types of innovation in the past, okay? Although we also know that definitely there's new challenges, right? And more maybe important new developments. But don't forget that we also have a lot of interesting things and exciting things in the past, okay? This is what I would like to really start, okay, with my reflection here, okay? And of course, I may focus more on those innovations more specific to mathematics, because obviously there will be other technological developments in general, or influencing or changing our learning and teaching environment, okay? And at the end, I hope that we can also think about what we have any experience in our classroom, okay? Not simply just the innovation, but how does it influence our teaching in the classroom as well. You can also see another key phrase in my title here, variation and invariance, because I think that this is a very useful framework for me to think about different kinds of analysis and reflections, okay? And throughout my talk here, I may like to look at what's the same and difference among the technological tools that we have. And at the same time, what's same and difference in the mathematical concept we are handling, okay? How it may change actually the things, the mathematical contents that we're going to teach and learn. And at the same time, is there any change in our teaching and learning, okay? Or what is perhaps something remain the same as well, all right? Of course, it's not simply just listing different kind of changes and invariance, but at the same time, try to make a richer connections among things, ideas, okay, making meanings, and even multiple ways of seeing, right? Can we see things in different ways? So this is maybe some of my major concern, okay, in this set of experience sharing and reflection. Okay, so that means maybe I can try to maybe invite you, okay, to imagine what we have experienced in the past. I mean, really, really long times ago. Okay? And although we have concern about new technology, new innovation, right? But perhaps you can also think about some similarly interesting things and exciting things in the past, right, that we have. Now, there's a lot of things to choose actually, okay? But I choose one of them to focus on today. Anyone know this calculator? Right? Have anyone used it before? Okay, so don't worry if you don't mind, okay, revealing your age, all right? You can let me know or let us know, right, whether you have this calculator. This is it's one of the very exciting calculators I have before, right? It's called TI-92, right? I would even call it a super calculator. Right? This is the first super calculator we have. And do you know when when we use it or when we have it? Any idea? Okay. I have this one, I think, in the years around 1997. Okay. And it is actually first developed in 1995. Okay. So it's back to the 1990s. Okay. So I would like to invite you to experience a little bit more about it. Actually, you can also try it on your own. You can see this page. Okay, so this is the calculator. Now I say that this is a super calculator because this is the first one we have for symbolic calculations. Okay, so what does it mean? You can scroll down and then find it. Actually, this is the model here, and you can click to open it. Okay, you can have a try. All right. Okay. So this is what I call a symbolic calculation or computer algebra system. Okay? You can try the rest. If you have time, you can play with it, and then you can see other useful tools within it, including geometry, spreadsheets, and also graphing. Okay? Of course, because basically it's a graphing calculator. Okay? So imagine, I hope that you get, of course nowadays you may not think that this is very special, right? But don't forget that I'm talking about 1997. Okay? And at that time, we just started to have computer, a very basic computer around us. Okay? And then suddenly we have this very interesting device in front of us. Okay? To me, it's like the first model of Iron Man. Okay? Can you imagine? Okay? So, for us, okay, we try to think about what can we do with this calculator and how we can make use of it, how we influence our teaching and learning. Okay, so you can see another page I put down here. This is, at that time, this was further promoted by some educators, like these two very important persons, Professor Birch Weiss and Professor Franklin Demena, okay, because they have a lot of training, okay, provided by teachers to promote the use of technology in general. Of course, at the same time, specifically the use of this calculator. Exactly because this handheld calculator, right, they start to think about different new ideas or possible ways of developing our teaching and learning. And at that time, you can see this page extracted from the journal article long times ago. At this announcement in 1997, they arranged a number of summer institutes, okay, in the US, and for the teachers there. I'm lucky to be able to join one of them in that summer, okay, 1997. I first arrived at Ohio, US, okay, on the 1st of July, 1997. A very simple date for me, easy for me to remember, right, the date. And so that is the training that we try to learn how to use the calculator. At the same time, learn a lot of things about teaching with technology as well. Okay? Now let me share with you one interesting incident in that workshop, okay, or summer institute, because at that time I was still a teacher in secondary school. Okay? So I have to apply for special leave in order to join that program in the US. Right? And when I arrived, I know that most of the participants are the local American teachers. Okay? As a few international participants, right? Like me, coming from different places. Right? For me, I'm from Hong Kong. Right? And then the organizer asked us, could you, each of our international participants, could you introduce something about your country, your places, right? And so to our local teachers. Now, actually, I find that the other participants already prepared for this because they have the PowerPoint, okay? But I was not unprepared at all. Right, so I just wonder, what can I do? And then I asked them, can I use a whiteboard, okay, and a marker, because I have nothing to prepare, and then I can just show them very simple things. And what I showed, so I used a whiteboard, right, and a marker here. See whether I can use the mouse to draw it, okay? So I try to tell them something about Hong Kong, okay, to the participants, particularly those are American teachers. So I draw something like here, okay? So at that time, I used the marker and the whiteboard. It's much better, actually, or the drawing, but I use the mouse now. All right, and the first thing I tell them about Hong Kong is that Hong Kong is a very mountainous city because it's very special and unique. You know that in such a modern city, you seldom expect a lot of mountains, okay, or hills, okay, so close to the city center. It's very spectacular. Even though at that time we don't have the documentary 4 trails that we have today, okay? But I think we still notice this is a very special phenomenon in Hong Kong, all right? And then I'm going to tell them another things about Hong Kong, which is also very important. So I continue to draw on the whiteboard. Okay? So believe me, my drawing should be better in the whiteboard with the marker. And then the second thing I want to tell them is that Hong Kong is an international city of finance. It's a very important financial center. Okay, so that is the second thing I would like the participants to know about it. Okay, so do you like this introduction? So this is the way I tell them what Hong Kong looks like. Okay, the 2 important things about Hong Kong from my point of view. Now I share with you this incident because actually later on when I recall, I try to remember it, I find that it also matched very well, okay, the theme of that workshop, or also the things that we're going to experience very soon. Because in the new technology there, what's emphasized is the multiple representation and different way of seeing the same ideas or objects, okay? Just like how I see Hong Kong in different ways. At the same time, I will tell you very soon, what's more important to me is not the technological tool itself, right? But the attention to different kinds of multiple ideas, multiple representation in mathematics, why it will influence our teaching and learning. Okay? But I hope that you can also imagine that what I'm telling you is quite also similar to how you experience or think about calculator influencing the arithmetic, teaching and learning, or even other areas. Right? I hope that you will think in this way. Okay, so this is just another device to help us to project the screen of the calculator onto the screen of the classroom. This is a very interesting tool for me as well. This is a screen cap from another old journal, right, showing activities using the calculator. What I want to highlight here is that actually we can use the same calculator for drawing the geometric situations. This is a classic swimmer problem in calculus, how to minimize the time for the lifeguard to reach the swimmer. So this is a geometric drawing provided by dynamic geometry, at that time Cabri geometry. And these measurements can be transferred to the spreadsheets in the calculator. Right? So you can study the variables, that means the time, the length, and so on, to notice the change. This is basically a spreadsheet. Okay? And then this can also be plotted as a scatter plot. So the points can also be visualized, and then you can imagine the change, and then try to understand when, how there can be a minimum time, for this. And of course, as I mentioned earlier, it is a symbolic calculator, So you can also use symbolic calculation to do the differentiation integration in order to find the exact value. All these are combined together in one device. So that's why I say not simply each individual tools is at that time was quite new to us, I would say that, But now we even combine it together in one device and then try to connect them or interlink. Right? These are all different representations, and then try to make use of it to help the student to learn. Can you see the big change at that time that we are facing, how exciting it is to us? So it's not Iron Man now, it's even Avengers, I would say that. Because we're combining each one of these two. Originally, each one of these two, just like dynamic geometry, they can have been their own story, actually, all right? But actually now we're combining them together. Now, of course, you wonder, actually, GeoGebra, another generations of Avengers, actually, to be. Just like the name, GeoGebra is the combination of geometry and algebra, And that's why, basically, I would say that I'm continuing in this way, But what I learned or what I first realized was my experience in using the TI-92 graphic calculators. And so let me share with you some of the expectation of the educators and teachers at that time. Once again, by Weiss and Demena, in 1997. So they emphasized that this can be an inexpensive device to be available to all students and portable. Now, why is it important? Don't forget that at that time we did not have smartphone and tablets. No one I will imagine that computers can go into the classroom easily, and even used by every student at that time. Can you see the main point here? Although no one can predict at that time, 1997, right? No one can predict that very soon we have entirely different types of device, okay? But this, anyway, no matter what device we have, this is a very important idea, okay? While we can have students, okay, using the individual tools, okay, to help them to learn, which is very convenient and portable, all right? Can it be done? Okay, so at that time, what we expect is the device like this, okay? And this will also change, okay? They call the CSA2 here is the computer symbolic algebra, right? So this is provided by a calculator, and then they also predict that they will change what we do in next 5 to 25 years, all right, in different countries and so on. Is it really like this? You can think about it, okay? Anyway, now what do they expect us to change, all right? It's not just only teaching more advanced mathematics students, right? I think behind this, more important is what I highlight here. At that time, already in the 1990s, okay, we hope that we can have can help students to have better mathematical understanding, or become good thinkers, communicators, and problem solvers. So if I put these words in nowadays article, I don't think that it is irrelevant, am I right? It seems that I can put these words, right, in different eras, different stages, all right, in different. That's why I say, even though we are on the journey of innovation, but to me, interestingly, this is a long journey, okay, and we have experienced it again and again in different ways. Of course, we hope that there's change, right, not simply just repeating, okay. So let's see how we go on, maybe from what we observe, perhaps. Okay. Now I share with you a little bit more about what is so special about all these major innovative tools in mathematics education, okay? Of course, we have a lot of new versions coming up, okay? But I think there are some central ideas really similar or maybe quite the same among different tools or different devices we have. Now, this is a handbook in 2017 around, okay, and coming after summarizing a lot of preceding articles from a very important conference about math and technology, ICTMT, okay. And the author here also tried to review what had been developed since the 80s and 90s, and then try to sum up with two key points, which I share, which I agree very much, actually, okay. So among all those devices we have, right, so we basically we are making use of those these two key ideas. One of them is about the concept of a mathematical figure and the new actions of dragging. Okay? Of course, nowadays we think that dragging with the mouse is very trivial, right, or maybe very simple. But don't forget that at the beginning, this is also a very different types of manipulation, right, that we can expect teachers and students to have. And what is the consequence? Now, I'm afraid that even nowadays, perhaps not many teachers, okay, pay a lot of attention to this seemingly simple idea, all right? And then further on, as I mentioned earlier, multiple representations in mathematics, okay? So not dragging in individual environments, but also you link up different representations together, okay? The dragging create different kind of changes. Once again, I'm talking about variation and invariance, okay? There are different changes that you can produce and then try to observe the relation and so on, okay? And so this is a little bit elaboration. This part is about the dragging functionality, all right? And also dragging objects within multiple representation, all right? And even, perhaps, this is also very fundamental ideas about modeling, which I also continue to elaborate very soon, all right? So, now, talking about dynamic geometry and dragging, okay, this is one observation from another educators, okay, Ruffin. In quite a lot of his studies, he tried to observe the teacher's use of the technology, and particularly dynamic geometry. And one observation I agree also very much. I believe that this is also common among us as well, right? Although there's a lot of possibilities of using dynamic geometry, okay, but quite often, perhaps the teachers may just focus on the very simple and superficial numerical values, okay? And then without paying too much into the actual geometric sense or ideas. Just like what I highlight below, okay, down below here, to what extent we really support the visual, spatial, and then the logical and deductive aspects of mathematical thinking. Now, this is not easy, I would say that, okay? And I will agree that this is also a maybe persistent or a challenge to us as well. So maybe let me try to demonstrate a little bit with one example. It is about the angle sum of triangle. And now talking about angle sum of triangle, I believe that you can find different applications nowadays to talk about this idea. Now, however, I will find that, first of all, not many teachers will like to spend time to explain the proof or explain the reasoning behind it. Now, it is fine from my point of view, all right? Even though you don't spend a lot of time to go through the complete reasoning or the logical proof, there's still a lot of things that you can work with the student to develop the sense, not simply just knowing the result, okay? And now this is also supported by dragging, of course, okay? Now because most of the time maybe we just focus on, let's say, just drag the triangle and then conclude that the three angles change, but adding together is 180 degrees. It's not that difficult for the student to remember. Probably they will see it very easily, and then I say remember the result, okay? Not that difficult. But I wonder how far do they really notice the size of the angles and the change in the size of the angles? Do you know what I mean? Okay? Or do they just see three numbers and then add them together? Okay? Or do they pay attention to the actual size? For example, if I move the point A upwards, all right, what will happen to this angle? You can ask the student, okay? And then how far can they tell that it will be smaller? And then you can continue to do so. Okay, so you can drag it like this, and then let them know I move the point A upward, and then let's see whether they agree that the angle is smaller and smaller. Can they predict it? Now, what happened to the two angles and the base? Okay, do they know that the two angles and base becomes bigger? But how big? Okay? Can they make a prediction? Can they make a guess? Okay? So this is the kind of question I think we can try to bring to the classroom. While we are dragging, not necessarily dragging by individual student, it can be dragging by the teacher, right? But we can also invite them to think about the changes, how the size of the angles vary. There are different ways to talk about the changes among the angles, right? Not just looking at the numbers or the measurement and then add them together. So I hope that you can understand understand this point here and try to emphasize. Okay, this is important because imagine if you don't pay attention to this spatial ideas or geometric ideas, then the common exercise in our textbook or the angle chasing exercise will look like a game of what I call arithmetic. Okay, do you know this game? This type of game, all right? So the numbers are put into these different cells, and then according to the rules, if you add the numbers in the circle, then you get the numbers in the square. Okay, and similarly, you can do it in the reverse manner. Okay, so these are quite some sort of common puzzles among students in earlier stage. All right. Now, what I mean is that the angle sum of triangle properties in our exercise look like games of arithmetic. Do you see what I mean? They are just playing games of numbers. They are not paying attention to the actual shapes of the triangle, the angles of the triangle. Because if you change the shape of this triangle, it doesn't matter. The rules is the same. Okay? So I wonder how far do they really pay attention to the actual change in the geometric properties, okay, while we are working on different kind of mathematical problem. Of course, you can go on to talk about the proof or something more related to the deductive reasoning. That is another type of activities you can try, but I may not have time to mention here today. Okay. So another major concept from the review, as I mentioned again and again, multiple representation. All right. So these have already been actually recommended for a long time. Okay, it's not a new idea at all. Just like what you see in the supercalculator I showed you in the 1990s. All right. And then there are different examples. This is also a book I extract from 1990, okay, a yearbook of NCTM, all right, and showing examples of this kind, okay, maximizing problem, maximizing the volume of the box. And then this is one of the expectations, all right, why they want to do this kind of activity. For example, according to author, the graph now we can have device to draw the graph quickly. So we can help the student to explore and discover mathematical concepts and use the graph to solve problems. Right? Drawing graph efficiently is just a technical part, all right? But more important is that Do they lead to better concept understanding, discovery, or maybe use the graph to solve problem? Now, I find that this is not an easy idea, although it started very, very long time ago, okay? And use the realistic application, okay, involving complicated algebraic representation, okay? So it may change the way we look at the curriculum as well, okay? So these are the translation. So it's also another extract from the article to demonstrate what's the importance of using this kind of tool. And this is another book of those years, okay, having another similar examples of maximizing the volume of a cone. Okay, if you want to try it, go to the GeoGebra book I show you. You can find my example here using the GeoGebra, all right? So these kind of things can now be done in different ways, okay, using different tools. But my point is, starting in a very long time ago, okay, how we already expect, I hope that our students will learn better from this kind of problem. Now, by the way, may I also ask you, if I show you this problem, this task, do you think that it is related to our curriculum? And what do you think you expect the students to learn from it? Okay, how would they learn, okay, from this process? Okay, particularly, can this be a task in ordinary mathematics classroom? Now, why I say ordinary mathematics classroom? Because perhaps some of you will say that, oh, this is good for enrichment, okay? Modeling competition, okay? So for those more elite students, or something like this, okay? But I always assume that this should be a kind of common task for most students, okay? Now, see whether you agree with us or not, okay? So this is also the time that we have a lot of opportunity, right, to explore and experiment this idea. So as I say that these all started very early already. Okay, now my point of view is that actually you can go on to analyze this task and then try to see what is actually included in it. From my point of view, it's so crucial because it incorporates some important ideas about learning the concepts of functions and variables, which is nowadays still a very big problem among our students and difficulty, okay? Due to different reasons, of course, okay? But I hope that we should also realize these challenges and important obstacles. By the way, if you use nowadays tools, obviously, the teachers will appreciate that we can draw graphs in a very simple way, okay? Because you can actually use GeoGebra or Desmo and then just type in very quickly ax squared plus bx plus c, and then they will handle the rest and tell you what a, b, and c are. Right? And then you just go on to drag the slider and change it. But don't forget that from my point of view, this kind of activity won't help the student more. Okay? It looks like that we are just accelerating the process, okay? Giving the answers more quickly. Right? Unfortunately, in most of the lessons I observe, okay, I don't see that there's a good opportunity for the student to learn from it. Okay? From my point of view, I don't think the actual change in the teaching in the classroom really happened, okay? Although we use different tools now, okay? But I'm afraid that there's still a lot of obstacles. Now, I will put it into this form, okay? I will call it different kind of dichotomies. That means this may influence the students, the teacher's decision, okay? In which way we will use or don't use the tools. Okay, and all these are not easy to actually to resolve. Okay, but I find that they may actually influence our teachers' decision how they use the technological tools. I say dichotomies, but I say perceived dichotomy because this may not be totally true in some sense. Depends on how you see it, how you combine it together, right? Otherwise, they will be very simplistic or lead to very simplistic decision. Okay, and finally, or more, I would say that you can find out more from the literature, okay, talking about how teachers can develop better use of the technology through the ideas or frameworks of the TPAC. That means the integrations of technological knowledge, pedagogical knowledge, and content knowledge. Okay? So these are also not particularly new to us already. My further suggestion is that in a recent handbook, I contribute a little bit here. I would say that maybe the variation theory can help us to look at TPAC in another way, just like what I emphasized, okay, change and unchanged, okay? So this is what I see, okay, in the TPAC framework, all right? So, and particularly, I would like to highlight that why I want to emphasize variation. This is also mentioned here, how I like to include it in the TPAC ideas. And also supported by some other examples recently in the HKMU, okay, conference last year. Okay, so finally, just come back to our journey. So that's why I say that this is a long journey, right, from my point of view. All right, we may not know where we go, but I hope that we'll enjoy this journey anyway. Okay, just particularly we have a lot of people around us, the professional community, okay, and teachers working together. At least we'll enjoy this process as well. Okay, thank you very much. Yeah.